Okay, for question number 36, it's asked how is electric current related to the potential difference across the terminals of a conductor, and this is what exactly is the Ohm's law. We have to draw a labeled circuit diagram to verify this relationship. So for first one, we can say that according to Ohm's law, so potential difference across the ends of a conductor or a metallic wire. So this is the potential difference across ends of a metallic wire is directly proportional to the current flowing through it. And the condition is that provided the temperature remains constant. Okay, this is the condition that the temperature remains constant. Okay. Okay, now we have to draw a label circuit diagram to verify this relationship. And let's draw the label circuit diagram. Let's say this is let this be the battery, and to the battery let there be a key, close key. This is a close key, and let there be an ammeter connector. So positive terminal of the ammeter is connected to the positive terminal of the battery. So let this be the ammeter. Let this be the variable resistance. This be the variable resistance rheostat, and it's connected. Let this be a device across. This be the resistance or the load resistance or the device across we will which cross with which we will get the output. So let this be the potential difference. Okay. And the current flows in this direction from positive to negative. So more is the potential difference, more is the current. So V is directly proportional to I, or we can say that I is directly proportional to V. More is the potential difference, more is the current produced or the current flows. Okay, now next question is why should an ammeter have low resistance? Now this is the ammeter which is connected in series, which gives us the reading of the current. Now that means that all current should flow through this ammeter so that it gives us the exact reading, and this will happen only when it has low resistance. So this should not obstruct the flow of the current. So that's why ammeter should have low resistance. And we can write here since ammeter is connected in series. So an ideal ammeter should have zero resistance, we can say. Or let's write it here for this. It's since this ammeter is it is connected in series and it should not increase. So we know that whenever a device is connected in series, it increases the resistance of the circuit. So it is connected in series, but it should not increase the resistance of the circuit. So we cannot take it out of the series. It should not increase, but instead we can have it, uh, we can make it so that it has a low resistance. So it should not increase the resistance of the circuit. And because it's giving us the reading, so that means it should allow maximum current to flow through the circuit. In the circuit, so ideally it should have low resistance or zero resistance. Okay, this is a reason. Okay, so now we have two VI graphs, and one is graph A and there is graph B. So A is for a series and the parallel combination of two resistors. We have to give reason why it's which graph shows series or parallel combination. So it's not given which one is parallel or which one is series. Now we know that more is the slope, more slope. This is the I versus V graph, sorry. So for V versus I graph, more is the slope, more is the resistance. More slope means more resistance. But this graph is not V versus I. This is I versus V. So I versus V means this is I versus V. Now this graph. So here now it's more slope means more resistance for V versus I graph. So I versus V means that less slope means this is less slope means more resistance. Okay, so that means this is the slope, the angle which, so this slope has less resistance, A slope has less resistance, this is less slope means greater resistance. And greater resistance means that A is in series because in series the resistance increases and the more slope means this is the more slope means less resistance. Less resistance means they are connected in parallel. Okay, so let's write down the answer now. What is the answer? So series combination is graph. So we can say that for series combination, it's graph. Less slope and more resistance for I versus V graph. I versus V graph. Okay, the parallel combination is B. So it's graph B because it has more slope means less resistance and that is for I versus V graph.
कितने चैप्टर हो गए बेटा?
Okay, let's move on to the next question.